Good morning, boys and girls. I hope you had a great long weekend with your family and that you got outside and enjoyed some of the nice weather. Even though it got really chilly, today it's been pretty nice this weekend aside from the rain. So I'm going to read a story problem today. And you might be wondering why we are looking at an equal groups organizer. And to be honest, there isn't any one person in our group that has totally mastered these equal groups problems. And also because today we're going to introduce a new organizer. And as we go, I'm going to be having you choose between what kind of problem it is based on the new information that we learn about array problems, because we've already learned about equal groups problems where we've got so many groups and there's so many in each group and we're looking for the whole, or they give us the total amount of something and we either have to find how many groups of this item there are, or we want to know how many there are in each group, which makes it a division situation. So let's get started. I'm actually going to use some cubes today, and I'm just going to use them as markers, just to kind of show where the information goes, okay? And so let's review very quickly where everything goes, because one of the things I noticed last week, really over the last couple of weeks, is that we're not always really sure about where our numbers go. I'm seeing a lot of people put the total at the top and looking for the total in division problems, and vice versa. We're just not really sure where those labels go or those numbers. So let's review. We've got number of groups. This bar is the number in each group, okay? And remember the number, if I have the number of groups in my problem, then I have to divide this whole into this many parts, not this. Like if I had 4 bookcases and each bookcase had 2 rows, I would not make 2 divisions here because there are 4 bookcases. I would need to make 1, 2, 3, 4 to represent the bookcases and put 2 rows in each bookcase. And then in that case, I would be looking for how many rows there are in all, okay? And so what I'm gonna do today is I'm gonna write down some information. I'm gonna use the cubes to determine just the parts. I'm not even going to necessarily write the numbers in the organizer so much as let's just review what these things are. So here's the first problem, okay? If you'd like to pause my video and solve the problems and the equations as we go, you may. It's totally up to you, but we are not really focused on that today. I really want to just focus on getting that key information where it goes on the organizer, okay? So these 2 colors are going to be the parts given in the problem. And this color is going to be the total, okay? All right, here we go. When the kids walked into the gym this morning, Mrs. Ortega had them form 3 groups of 8 students. And I want to know how many students there are in all. So I'm going to write down the information. We've got 3 groups. And there are 8 students in each group. And I want to know how many students in all. Okay, so remember, I've got numbers of groups, number in each group, and the total. Well, in my head, I'm looking at kids. I see them walk into the gym, and kind of like Coach Kesselman, he might tell you when you come in, all right, I need you in 3 groups, right? So I'm going to use blue as my group. So that's how many there are. There are 3 groups. And I would divide this into 3 equal parts, right? And there are 8 students in each group. So I've got 8 in this group, 8 in this group, and 8 in this group, right? And I want to know how many in all. So I've got groups and students, and I'm looking for students. So definitely either multiply or divide. And because my question is asking for students, I'm going to put a little star by the 8 because that's also talking about students. If there are 3 groups with 8 in each group, are there more than 8 students in all or less than 8 students in all? And notice that I'm looking for this total. That should give you a really big clue. The only time I'm looking for the total is in a multiplication situation if I've got equal groups. The other time that I'm looking for the total is in an addition or a subtraction situation. But my labels don't match here. I'm not adding or subtracting. I can't add 3 groups to 8 students and have those 3 groups magically turn into students. It doesn't work that way. I can only add and subtract things that are the same. So in this case, we are multiplying. And so I've got 3 groups of 8, right? And as I said, we're not going to necessarily solve, but I just wanted to do some review with you to work on where this information goes on our organizer. All right, let's do another one. Let's keep talking. That was pretty good. So after they did some stretches, Mrs. Ortega had the 24 students. I'm going to write that down. She had the 24 students get into groups of 4 to play a game. And I want to know how many groups were there. So I've got students, and I'm looking for groups. Oh, ding, 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 ding. Remember, we learned that when the information in the story is talking about the same thing and the question is asking for something different, it is an automatic D1, which is a division situation. Now, boys and girls, do I know the total number of students? I do. The total number of students is 24. And that goes at the bottom. The total goes here. If I were using a number, I would put 24 students right here. Okay? So, but remember, this red is here. So I'm just going to cover that. All right? Now it says we have groups of 4. That means there were 4 students in each group. So this is a group of 4, this is a group of 4, and we are looking for how many groups. So our question kind of gives it away, right? We are looking for this. Now I said this red cube was going to be our unknown, what our question was, right? So let me go ahead and just use a different color for this. We know that there were 4 students in each group, and we are looking for how many groups are there. So I've got students, and I'm looking for groups, an automatic D1. So I'm going to write my division equation, which is 24 divided into 4, and then I can find my answer from there. That was a tricky one. Very good thinking though. All right, let's erase, and we will do another one. All right, at the end of gym class, Ms. Ortega asked the 24 students, so again, I'm gonna write 24 students, to form 2 lines at the door. And we wanna know how many students were in each line. So how many students in each line? All right, so remember this red square is our question, and then these are gonna be our parts in our story, right? Or the parts of the story. So I've got students and lines, and I'm looking for students. My labels do not match. I do not have the same labels in my story, and then my question asks me for something different. So I really need to think about this. If there are 24 students in the gym, and the teacher wants to put them into 2 lines so that there's the same number in each line, what am I looking for here? How many students in each line? If I'm looking for the students in each line, am I looking for the total number of students? Well, it tells me the total number of students in the gym, which is 24. So I'm gonna put that there. And it tells me that there's 2 lines. So in my head, I can see 1 line here and 1 line here. So that's actually the groups. And it actually says how many students in each line, number in each group. This time I'm looking for this. Now, if there are 24 students in the gym and we're putting them equally into 2 lines, are there more than 24 students in each line or less? Well, if you said less, you are correct, which makes it a division problem. So we've got 24 students divided by 2 lines, and then we would look for the solution for that. Now that was a quick little review, not meant to take our whole regular time, but just a little review of equal groups problems and a review about where we put the information on the organizer. I would like to introduce to you today a brand new organizer, which is called an array problem. This is our organizer for array problems. Now, what is an array, you ask? Well, you'll have to put your thinking caps back on. But in 2nd and 3rd grade, we talked about how arrays are shapes. Could be a rectangle, could be a square, but there is an equal number of rows and an equal number of columns. And together, they either make usually, always a square or a rectangle, but they help us represent multiplication and division problems. So I'm going to introduce this organizer to you today. We're going to work through some problems together. Going to be using some blocks, this time only 2 colors, to model a situation in the story. So I want you to listen to the story. Lately, I've been noticing arrays wherever I go. At the post office, the grocery store, the pet store, even when I'm just walking down the street. Just yesterday, I passed a building with a large window that had 4 rows of little window panes. There were 6 little square window panes in each row. I want you to close your eyes for just a few seconds and imagine a window like that. I want you to listen to the story again, and then let's build the array after we've described it the next time. I passed a building with a large window that had 4 rows of little windows. There are 6 little square window panes in each row. If you close your eyes for a few minutes, as I hope you've been doing, then you should have seen something like this. So I'm just grabbing some. So I heard in the story that there are 4 rows and 6 little window panes in each row. So here's my first row. It's got 6 window panes in that row. Here's my second row with 6 panes in each row. Here is my third row with 6 window panes in each row. And here is my fourth row with 6 window panes in each row. So along the side, I've got 1, 2, 3, 4 rows. And I've got 1, 2, 3, 4, 5, 6 in each row. All right. Now, I want us to look at this array that we've just made, and I want us to look at the organizer. I want you to pause for a minute, and I want you to think about where the information about the array we just described, where it goes. So look at the rectangle. We're looking for the total number, and that goes in the middle, describes the whole array. Over here we have the number of rows, and over here we have the number in each row. So we know that there are 4 little rows of square window panes. So I'm actually going to put the 4 over here to represent the number of rows. And in the story, I heard that there were 6 window panes in each row. And the question wants to know how many window panes were there in the whole window. So I am looking for the total. So I've got rows and window panes, and I'm looking for window panes, which means we are going to be multiplying. Because if I have 6 window panes in each row, and I've got 4 rows, I've got way more than 6 window panes in all, correct? And I multiply when I need a bigger answer. So I've got 4 rows of, or groups of 6. So I'm going to be counting by my 6s 4 times. 6, 12, 18, 24, which means I've got 24, and this is important, window panes. Now, boys and girls, if you did not get all 10 points on your progress monitor last week, one of the things I noticed was we had a lot of right answers, but not a lot of labels. Some of you did label, but not all of us. So I want us to really get in a habit of putting that label on there, okay? Very good job for your first array problem. Let's try another one. Let's try another one. Get rid of that. Okay. I went to the post office a little bit later to pick up a package, and right there on the wall, I saw 8 rows of mailbox doors with 10 in each row. So think about that story. If I've got 8 rows, I'm gonna build my rows. There's 1, 2, 3, 4, because my rows are gonna go across, right? 5, 6, 7, 8 rows. And I need 10 mailbox doors in each row. I don't even know if I have that many cubes, boys and girls, but I am gonna go ahead and build as much of this as I can together. So we've got 2, 4, 6, 8, 10 in this row. We've got 7, 8, 9, 10 in this row, right? This is going to be a much larger array than the one before it. 1, 2, 3, 4, 5. 10 on this row, and I'm actually out of the rest of my green and blue colors. Oh, nope, actually I have another one of green. Hold on. Sitting right beside me. All right, here we go. So you can see, boys and girls, if I were to continue on building my array, which I actually guess I could. Let me just grab another color of blue. And we'll continue on. Looks almost purple next to it, but it is really just a dark blue. So we've got 10 in this row. Ten in this row. Oh, here's some more lights. 5, 6, 7, 8, 9, 10 in this row. Last one. I'll get them all straightened up here in just a sec. Ah, finally. That was a long one, wasn't it? Okay. But if you are making this picture in your head and you're thinking about the information, we are thinking about 8 rows of mailboxes. 1, 2, 3, 4, 5, 6, 7, 8 rows. And there are 10 mailbox doors in each row. And I want to know how many mailbox doors there are in all. So I'm going to scoot this up a little bit and pull in our organizer for this problem. So remember, I've got number of rows, the number in each row, and I'm looking for how many mailbox doors in all. So I've got 8 rows, 10 mailbox doors in each row, and I want to know how many mailbox doors there are in all. So if I've got 8 rows of mailbox doors and 10 mailboxes in each row, do I have more than 10 in all or less than 10 in all? If you said more, you are correct. And I get more by multiplying. So I have got 8 groups of 10, which equals 10, 20, 30, 40, 50, 60, 70, 80 mailbox doors, because the question asked how many mailbox doors were there in all. All right, let's do a few more of these. At this point, if you would like to grab a paper and a pencil and work alongside me or with me, I think that would be super duper. You can pause this video at any moment that you need to, okay? All right, this time I'm not going to use the cubes. They take just a little bit of time, and I think we get the idea with building the arrays, okay? I want us to just use our organizer for a moment. I'm going to write the information down that's important. So after I left the post office, I stopped at the grocery store to pick up a few things for dinner. I saw a display of tissue boxes at the end of one of the aisles. There were 5 rows of boxes with 9 boxes in each row. So I want you to imagine 5 rows of boxes. I want you to imagine 9 boxes in each row. And I want to know how many tissue boxes were on display. So I've got rows in, boxes in. I'm looking for boxes. My labels do not match. I'm either multiplying or dividing. Now in my picture, I can see the 5 rows. So I've got to figure out where to put my information, right? Remember, question, parts of my problem, right? So the 5 rows goes here in the number of rows. The 9 boxes in each row goes in the number in each row. And how many boxes were on display is looking for the total. Because if I have 9 boxes in each row and there are 5 rows, do I have more than 9 boxes altogether or less? Well, I've got more, and more means multiply. So I've got 5 groups of 9. 9, 18, 27, 36, 45, which means I've got 45 what? Tissue boxes. All right, boys and girls, this has been a really good lesson. I am so proud of you, thankful that you participated today. If you will, when you are finished watching the video, click that you've watched this assignment. Just hit turn in so that I know you participated in today's assignment. Tomorrow, we will review, and then we will work on our very first assignment with array problems. I'm very proud of you, and I'll see you tomorrow. Glad to have you back. Bye.